In these notes, we're going to be looking at evaluating functions written in function notation, which is just sort of a special notation that tells you what the input value is of any specific function. So we might be used to seeing equations written in what's called xy notation. And here's an example, y equals 2x plus 3. That's written in xy notation, and you can kind of see why. We've got x and y in the equation. Y equals 2x plus 3. Now for function notation, what we're going to do is set this up as a function of x being the input variable right here. So all we do is replace y with this sort of instruction container, f parentheses x, which is read verbally as f of x, or a function f of x. And so that just equals 2x plus 3. So all this first thing, this f of x does is tell you that we're going to use the f function and our input is x. And that's why we see an x in the equation. It's a little easier to understand if we do some examples, so let's get right to it. Example A, we have, first of all, we have given the functions f of x equals 4x plus 10 and g of x equals x squared plus 3x plus 2. Find each value. And so we're given two functions, f and x, or sorry, f and g. So the first example just uses the f function. Now this, like I said, this function notation piece, that's just the instructions. This is just telling you which function to use and what to put in for the variable. So this says f of 3, which means we're going to use the f of x function. And the important part, the part that we're actually going to be using, is just the 4x plus 10 part. Because again, the f of x part is just the instructions. So we're going to write 4x plus 10, but instead of x, we're going to plug in this 3. All right, so we're just replacing the variable with our input, which is 3. And that's all this says to do. Use the f function with an input of 3, and just replace each variable with that input, which is 3. And then we just evaluate. So 4 times 3 is 12. So we have 12 plus 10. And 12 plus 10 equals 22. And that's the answer. Notice this f of 3 didn't come into play at all after we used it to know what problem we're actually evaluating. Nowhere in here did we use f of x, f of 3. It just told us what numbers to use. So our answer, 22. That was a pretty simple example. Let's see what happens when our function is slightly harder. So we have the g of x function, which is x squared plus 3x plus 2. And we're told to evaluate g of negative 3. So just similar to the problem we just did, we're going to plug in negative 3 into that function. So anytime you see an x, we replace it with negative 3. Just like that. So instead of x squared plus 3x plus 2, now we have negative 3 squared plus 3 times negative 3 plus 2. And now we just evaluate. Negative 3 squared, that's negative 3 times negative 3 is positive 9. 3 times negative 3 is negative 9. Oh, I wrote 3, negative 9 plus 2. And again, we keep simplifying. 9 minus 9 is 0, and 0 plus 2 is just 2. So there's our answer. Again, we were able to evaluate all the way down to a single number. We didn't use the g of negative 3 anywhere else in this problem. It just told us what to use, what function to use, and what the input value is. All right, last example in this section, f of x again. We have f of 2y. So we're going to use the f of x function, which is 4x plus 10. But instead of x, we're going to put in 2y. So whatever is in the parentheses here, that's your input value. That's what you put in for the variable, no matter what it is. Excuse me. No matter what it is, that's what you replace x with. So we have 4x plus 10. We're going to replace x with 2y. So we have 4 times 2y plus 10. All right, now we just evaluate. 4 times 2y is 8y plus 10. And now this is where very commonly students will attempt to solve this equation. But this is all we can do. Remember, we don't use this at all. We just evaluate that function. So this is the most we can evaluate. We don't know what y is, so we can't get a number here. We just have to stop. So the answer here, our function at 2y is equal to 8y plus 10. Let's keep going. Same two functions. We have f of x equals 4x plus 10. And we have g of x equals x squared plus 3x plus 2. Same two functions. Just slightly harder. So now we have 2 times g of 2a. So here's the function part. We're going to use the g function with 2a as the input. Right? That's what's in the parentheses. And then the entire thing is going to get multiplied by 2. So let's write this out. I'm going to write the 2 first and brackets again. But inside the brackets, I'm going to replace this g of 2a with the actual function. So it's x squared plus 3x plus 2. And every time I see an x, instead I'll write 2a. So we've got 2a squared plus 3 times 2a plus 2. Looks a little messy. We can clean it up. 2a squared, that's 2a times 2a. That's 4a squared. 3 times 2a is 6a. And then plus 2 there. Now all this is going to get multiplied by 2. So again, we're just going to distribute that and multiply each term by 2. So 4a squared times 2 is 8a squared. 6a times 2 is 12a. 2 times 2 is 4. Now, looking at this, there is actually nothing else we can simplify. There's no like terms anymore because a squared and a are not like terms. We're not solving an equation here. We're just evaluating the function, so that's it. That's all we can do. Let's look at example E. We have the f of x function right here. It says f. So that's 4x plus 10. But instead of x, we're going to put 2 minus x. And that's fine. We have an x in there, but that's okay. Whatever is in the parentheses, you replace the x in the function with whatever's in there. So we got 4x plus 10. We're going to do 4 times 2 minus x plus 10. So we'll distribute, we'll multiply. We get 8 minus 4x plus 10. And then our last step is to combine like terms if possible. We have 8 and 10. So negative 4x plus 18. Or 18 minus 4x if you like that better. But typically the variable term goes first. One more here. Back to the g of x function, which is x squared plus 3x plus 2. And we're going to input 2 for x, and everything is going to get multiplied by negative 4. We'll put that negative 4 out here. And then I'm going to write the g of x function, x squared plus 3x plus 2. But every time I see an x, I'll instead write a 2. So 2 squared plus 3 times 2 plus 2. So let's simplify a little bit before we multiply by 4. So 2 squared is 4. 3 times 2 is 6. We still have a 2. Can actually do one more round of simplifying. 4 plus 6 is 10, plus 2 is 12. So our solution here is negative 4 times 12, which is negative 48. Now we were able to get a number for our answer here because our input 2 was just a number. If it had had a variable like x or a or something, then that would show up in our answer. All right, let's go one step harder. New functions this time. F of x equals 3x minus 12, and g of x equals x squared. So now you see on example G here, we have f of g of x. So we're using the f function, and the input is the entire g of x function, which we know is x squared. So what you can think of this as is f of x squared, right? Because that's what g of x is. It's x squared. So what we're going to do is write out the entire f of x function, but instead of x, we're going to put x squared. So that's 3 times x squared minus 12. And really, that doesn't change much. 3 times x squared is just 3x squared. So that's all that is. All we did was replace the x with an x squared. But this does introduce the idea of putting an entire other function as the input on a function that we've got, which we'll see in example H right here. So we have g of f of 3. So this time we're using the g function, but the entire input is f of 3. So we're going to use the f of x function, evaluated at 3, and then plug that into the g function. So let's find what f of 3 is. And I'm going to do this down here to save space for the actual problem. So this is 3x minus 12, but instead of x, I put a 3. 3 times 3 is 9. And 9 minus 12 is negative 3. So I know that f of 3 equals negative 3. So now I can go back to my problem, and instead of g of f of 3, now I know that f of 3 is equal to negative 3, so I can just do g of negative 3. So I find my answer for f of 3, and I plug that into the g function. So that's negative 3 squared, which is 9. Negative 3 times negative 3 is positive 9. Okay, last one here. We're going to use both functions in this problem. We have g of negative 3 minus f of 2. So we're going to have to find both of these before we can do the problem. Now g of negative 3, I know already because I just did it over here. G of negative 3 is equal to 9. We just did that. So now let's find f of 2. Now I'm going to use the f of x function, 3x minus 12, but instead of x, I put a 2. So 3 times 2 is 6, and 6 minus 12 is negative 6. So I know that f of 2 is equal to negative 6. So there I have two pieces of information that I needed for my problem. And now I'll just replace g of negative 3 with 9, and then I'm subtracting f of 2, which I'll replace with negative 6 because we found that to be negative 6. And so what my problem really is 9 minus negative 6, which is just 15. So this one used two functions, but we evaluated each of them. G of negative 3 is 9. F of 2 is negative 6. So 9 minus negative 6 is positive 15. So there you have function notation, which looks confusing, potentially, but just remember, this notation here, this f of x, this is just the instructions and it tells you which function to use and what to replace and plug in to x to evaluate the function.